Section 11.5 is titled Polygons. In this section, you'll be able to classify polygons and also determine the sum of the measures of the interior angles of a polygon. So first, let's classify some polygons. A polygon is a simple closed figure that's formed by 3 or more line segments or sides. And I would like you to put this chart in your notes. We have the title of the polygon followed by the number of sides. Several of these you probably know, and some it maybe is just a refresher. A triangle has 3 sides. Quadrilateral has 4 sides. Pentagon 5, hexagon 6, heptagon has 7 sides, octagon 8, nonagon has 9, and a decagon has 10. So let's determine whether the figures are polygons. In example 1, if we count the sides, it has 1, 2, 3, 4, 5, 6. It has 7 sides. It is an enclosed figure. We don't have any open edges anywhere. We don't have any rounded sides. So this is a polygon. Example 2, if we count the sides here, we have 1, 2, 3, 4, 5, 6. It has 6 sides. It is a closed figure. Again, we don't have any curved lines or open edges anywhere, so yes, this is also a polygon. Number 3, however, is not a polygon. Polygons cannot have any rounded edges, so a circle is not a polygon. So this is no. So now you've seen several examples of what polygons look like and what they don't look like. A diagonal, when drawn in a polygon, is a line segment that joins two non-consecutive vertices in a polygon. So in a quadrilateral, you can draw one diagonal. You can either draw it from this corner down to the bottom right, or you could draw it the other way, from the top right to the bottom left. But we can draw one diagonal from this vertex. A pentagon, which has 5 sides, you can draw 2 diagonals from any one vertex. So we've picked this vertex here and we've drawn a diagonal across and then down. Remember that diagonals cannot be drawn from consecutive vertices, because if I try to draw one here, I'm actually on the outside of the figure. And you'll notice that what happens here is you create some triangles. Created 2 triangles in a quadrilateral. In the pentagon, when we draw the diagonals, we create 3 triangles. A hexagon, if we focus on this vertice down here and we draw a diagonal to the non-consecutive, so I can't draw it to this one, but 1, 2, 3, it creates 4 triangles. And an octagon, when we focus on this vertex, we can draw 5 diagonals that create 6 triangles. And we're going to use this idea about how many triangles can be drawn inside of a polygon to help us understand the angle measures of the angles of that polygon. So an interior angle is an angle that's formed at a vertex. So a quadrilateral has 4 interior angles. A pentagon has 5 interior angles. A hexagon 6 and an octagon 7. So the number of interior angles of a polygon is the same as the number of sides. So let's look at the theorem to find the interior angles of a polygon. So here we have a picture on the right, and it is a pentagon. It's a 5-sided figure. We've drawn 2 diagonals from the one vertex that create 3 different triangles. So if we're trying to find how much the angles add up to, remember a triangle adds up to 180. Remember that a square or a rectangle or basically any quadrilateral, those add up to 360. But if we want to look at any other polygon, for example an octagon or a nonagon, a hexagon, we find the sum of the angle measures by taking n minus 2 and then multiplying that by 180, where n is the number of sides. So we're going to subtract 2 from the number of sides from the figure, and then we're going to multiply it by 180. Because if we go back and look, remember that triangles are 180 degrees. So if we were to add up the outside angle measures here, we have two triangles. So it'd be 2 times 180. That gives us the 360. We know that a quadrilateral is 360 degrees. So it's 2 less than the number of sides. It has 4 sides, but we can only make 2 triangles. The pentagon, notice, is 5 sides with 3 triangles. So again, it's 2 less. So if I ask you to find the sum of the measures of the angles of a nonagon, first we have to remember how many sides a nonagon has. And a nonagon has 9 sides. So we're going to take the formula, and let's write it up here again, n minus 2 times 180. Well, n is 9, so it's 9 minus 2 times 180. 9 minus 2 is 7, so we're going to do 7 times 180. And that's 1260. So the angle measures of a nonagon will add up to 1260 degrees. Here we are asked on number 5 to find the sum of the measures of the angles of a 13gon. And once we get past 10, we can say 11gon, 12gon, 13gon, and so on. So a 13gon obviously has 13 sides. So we're going to use our formula, n minus 2 times 180. Remember that n represents the number of sides. So it has 13 sides. We're going to subtract 2. Multiply that by 180, so it's 11 times 180. And that's, whoops, and that equals 1,980 degrees. So the measures of the interior angles of a 13gon are 1,980 degrees. So we can now classify polygons. We looked at some examples, I believe it was numbers 1 through 3. And then examples 4 and 5, we were able to determine the sum of the measures of the interior angles of a polygon. In class, we will work on worksheet 11.5.